David, did you see this article? Some clowns in the US federal government have decided that it would be a good idea to ban gas stoves because they say gas stoves produce too much pollution. So let's ban them. What do you think about that?
Bjorn, I wish we had a working time machine. We would have included that in our video 27, Free Energy is Freedom, where we discussed Operation Winterkill. Seriously, many politicians are compromised, and as we presented in video 27, until we have a free energy device operating in our basement, attic, or garage, we are vulnerable to interruptions to our electricity coming through the electric grid or to the flow of natural gas originating from wells and transported through a network of pipes to our homes. These interruptions can be caused by extreme weather events or by intentional sabotage. Someone even blew up the Nord Stream pipelines delivering natural gas from Russia to Germany. And with the recent revelations in the news, which I find quite disturbing, I would say that it is clearer than ever that we do not want to be dependent on anyone else for our energy supply.
David, I think you're absolutely right about that.
And speaking of which, Bjorn, you are all set for the rest of the winter. You have a wood stove and a pile of cut logs. You will be able to stay warm. Maybe I could come and visit you if things turn bad.
Of course, David, you're always welcome. So welcome to our viewers. David, where are we actually going today with video 29?
Well, here's a reminder about something we introduced in our previous video, number 28, for viewers who have somehow personally experienced the invention or the suppression of a free energy technology device. We offer to present a video you send to us, all or in part, depending on length and your wishes, and feature it in one of our videos, and giving you credit if you are okay with going public with it. We provide more details in the description below.
Yes, David, that is an important point, and if you would rather stay anonymous, that's okay too. In either case, please submit your video or videos to, let's make sure we get it right here, submitenergyvideo@gmail.com. So the email address is submitenergyvideo@gmail.com. And we are ready.
We're looking forward to more videos coming our way. So Bjorn, are there any comments sent by viewers that we should talk about?
We've had a few comments on the videos, and there's particularly this one here from a viewer named Brian that I would really like to read to you and then have your opinion about it.
Proceed to read.
Okay, so here it is. Great video, gentlemen. Thank you. Great video, gentlemen. I'm in the process of figuring out how to send you a video about an experience that I had. It is not exactly along the lines that your great many wonderful videos have put forward, but I think that this experience is still relevant. I do not regularly speak about this because it can be taken as a woo-woo type of weird thing, but I will give a brief description of what my video will be about. I grew up in a small prairie town and often would go for country drives out through these seldom used back roads between huge fields of land. These roads were just two-wheel tracks in the grassy boundary between these fields. One Saturday afternoon in the mid to late 1970s, my uncle and I were driving down one of these roads out on the big flat top. The land is very flat there and without trees, so you can see for miles in every direction. We were heading east and just coming to a crossroads of two of these grassy back roads. This was out in the middle of nowhere when right in front of us, heading north, was this object. It was flying about 2.5 feet above the ground. My uncle shouted, "Look, a floating baloney!" There was a beige-colored object that did look like a whole baloney, or some would say cigar shape. It just cruised straight through the crossroads in front of us. My uncle jumped on the brakes of his old Chevy half-ton, backed up real quick and chased after the floating baloney. This thing stayed in front of us for at least 10 minutes, so we got a good look at it. It was only going about 15 miles per hour max. The peculiar thing was that with every small rise and fall of the road, it would maintain the exact same distance from the ground. How does this fit with infinite energy? This vehicle, or whatever it was, had no emission trail, was using some other form of propulsion that we had not ever seen. As I said, we followed it for about 10 minutes, and then it seemed to get further and further in front of us, even though we sped up. And then, in one of its up and down, level to the land adjustments, it just disappeared. And my uncle was not, "Oh my God, we just seen a UFO." No, he just casually said, "That thing had no exhaust pipe." And we turned east at the next crossroads and barely spoke about it again.
Wow! Now that's a comment. I will need to get my speculation cranked up for that one.
Okay, well, please do, David. Get that speculation cranking, because from our viewer's description, that object, whatever it may have been, had no propeller, no wings, nothing was emitted or exhausted, but there it was. So, can you speculate on what might possibly have enabled it to levitate?
Yes, indeed. In my video 8, in this video series, I presented what I had learned about lifters. I have seen these up close, but not too close because they require a very high voltage to levitate. Lifters also do not use propellers or wings. Now understand that those lifters can only lift about 1 pound or so. But maybe someone from somewhere has advanced lifter capability to levitate far more than just 1 pound. That could possibly explain how the object that Brian and his uncle saw could levitate. The lifters I saw back in the early 2000s, I described in volume 1 of my NASA Contractor reports. And these are, we have links below. This is volume 1, this is volume 2. And you can download these free of charge.
All right, that's important, and I highly recommend you do that. Since we've started down the road of speculating, though, David, do you have any other ideas of what might have kept that strange baloney-shaped object floating in the air?
Your Honor, since we only know what we've been told by our viewer, let us leave that for some other day. But thanks to Brian for bringing us this story of what he observed. I hope this will inspire other viewers to share their stories or experiences.
Okay, fair enough, David. And yes, it is fun to interact with our viewers. And beyond that, what we already covered here, what do you want to talk about as, say, the main topic for today's video, video 29?
Bjorn, as you know, we report on a wide range of energy topics. And I recently came across a short video presenting the strange properties of a metal alloy, approximately 50-50 nickel and titanium, called Nitinol, studied at the U.S. Naval Ordnance Laboratory in the late 1940s. Its name derived from Ni for nickel, Ti for titanium, and NOL for Naval Ordnance Laboratory. Put them all together and it makes the word nitinol.
Nitinol, okay. You say it's strange, so what kind of strange is it and how strange is it?
It has a memory and it can change its shape by itself with a little help.
David, I think you're setting me up for a joke, right? I'm not going to fall for that.
Bjorn, people tell me I'm too serious. Seldom do I joke. But what I said is absolutely true. Our viewers can purchase a piece of nitinol wire online as we did. The link is below. And experiment, I mean have fun with it as we did. So this is a 5 feet long by 1 millimeter diameter piece of nitinol wire.
Yes.
And we're going to show how we experimented with it.
We will do that. And
Yeah,
so,
right.
yes, I have actually seen this, so I know it's not a joke, and it is fun.
It
I have
is
to
fun.
agree with that, but just don't get too close, your face too close to it when it performs.
Roger that. So when one purchases a piece of nitinol wire, the manufacturer has given it a heat treatment at many hundreds of degrees, which causes it to change its shape at a remembered, or we would say less dramatically, at a preset temperature. The wire we have here has 104 degrees Fahrenheit on the package that it came in. Now that's no more than the daytime temperature in the summer sunshine in many parts of the United States.
That's right, and we played with this one recently in David's kitchen sink and filmed it in slow motion with my phone so we could play it back to you in slow motion.
Indeed we did. Start with a container of warm water. We just picked 110 degrees above the 104. Drop, we call this coiled up, it was just, wound up like that. Drop that into the warm water with your face not too close. I learned that the first time. And observe what happens. Well, the coiled up rapidly becomes straight. Let the wire cool, coil it up again, and drop it in warm water again. Watch it turn straight again. Continuous fun.
Continuous fun. And in slow motion you can see better exactly how it behaves, whereas just looking at it with a bare eye in real time it looks
fast.
almost instantaneous, right? And so let's take that fun with us into something that is actually of, or at least could be of, great importance, because some people realized with this metal, and this is now over 50 years ago, that these properties of expanding and contracting due to the memory property of nitinol, caused by only a very slight difference in temperature, had unique engine written all over it.
That's where fun becomes an important source of what I call green energy. Conventional heat engines, which burn a fuel to make hot gases to push a piston, or burn a fuel to vaporize water in a boiler to run a steam turbine, could not possibly use the narrow inlet to outlet temperature range suitable for a Nitinol engine. In fact, the reporter in the following CNN video clip states that 2/3 of the energy used for heating in industrial countries ends up as warm water going down the drain. I believe that Nitinol engines could significantly decrease that loss.
David, I agree, and let us have a look at that video.
This is the McDonnell Douglas Astronautics Company's Systems Center, a huge research and development complex spread over 250 acres here at Huntington Beach, California. Most of the work done here is associated with the American space program. But for several years now, a small group of scientists here has been investigating a strange new space-age metal, a nickel-titanium alloy called Nitinol. And a couple of years ago, the Department of Energy invited the people at McDonnell Douglas to investigate the potential for Nitinol heat engines and Nitinol power plants.
This is what they came up with, the world's largest operating prototype Nitinol heat engine. It is running on warm water, and the scientists here at McDonnell Douglas say it may have an overwhelming cost advantage over oil, gas, or nuclear-generated power. Even more amazing, no one knows exactly why this machine is working because no one knows exactly why Nitinol behaves the way it does. In cold water, Nitinol turns soft. Bend it and it stays bent, but in hot water it springs back with forces as high as 55 tons a square inch. No one knows quite why this happens. Several years ago, McDonnell Douglas began experimenting with Nitinol in the form of springs. At room temperature, the Nitinol wire springs bend easily, but in warm water they spring back, thus forcing the wheel around. Even stranger, Nitinol wires get stronger the more they're used. They develop a double memory. They not only contract in the warm water, but they begin to stretch of their own accord in the cool water. Nitinol can be trained. McDonnell Douglas then went on to the next stage, using a Nitinol spring belt running around pulleys, cycling between cold water and warm water. The tension on the belt drove the pulleys around. The Department of Energy then asked McDonnell Douglas to see if this device could be upscaled. A team of scientists at McDonnell Douglas's Engineering and Technology Department, led by Dr. Janelle, spent 2 years on the project, and this is the result. This engine has just been unveiled. Hardly anyone expected it would work so well. It seems to have profound implications. I asked some of the scientists at McDonnell Douglas how long it will be before Nitinol heat engines will be making a substantial contribution to world energy supplies.
That's a very tough question to answer, and one of the reasons is because the economics haven't been completely studied. We still need to know the price of materials and the price of a developed heat engine. Right now it looks very, very advantageous to us. That is, we think we can convert energy cheaper than by other means, low-grade thermal energy currently being thrown away.
The Nitinol engine is a fairly simple, mechanically simple device. We believe that one can couple small modules of an engine to produce engines that would generate larger amounts of power. And in principle, one could stack these things as thick as possible and come up with an engine that might generate 5 megawatts or so.
I think my favorite application in a small engine would be for irrigation. And the thing that's interesting there is that you can use the engine, the power source for the engine is merely the difference in temperature between the water that's going to be pumped and the air temperature. So almost magically you have a device that will be able to lift water from one level to another.
The McDonnell Douglas scientists say that Nitinol heat engines could run on solar heated water or on the temperature differences between the upper and lower levels of the oceans and lakes and dams. It could also run on waste heat, which at present accounts for the loss of nearly 2/3 of all energy produced in industrial nations. Research is now underway into Nitinol heat engines in the United States, Europe, Japan, and China, devising ways to harness the unique characteristics of the most remarkable metal we have known. Kevin Sanders, Cable News Network, Science Report.
Wow, and that video clip, I believe originally aired in 1982, and I understand that you have also found an interesting research paper from approximately the same time frame, written by engineers who looked deeper into the possibility of building significantly larger Nitinol engines for extracting mechanical power, which then again would translate into electricity, from water which is merely warm. And there is a link to this report in our video description.
Yes, and we are only able to skim the surface of their research in our video. The authors of this 1981 paper remind their readers that the amount of water available at, for example, 104 degree Fahrenheit temperature, which is 40 Celsius, that amount of that water is, in their words, immense. Some sources would be industrial waste heat, geothermal hot water, and oceanic thermal gradients. But such heat sources are not applicable for conventional heat engines.
Right. And David, I think what you are actually describing here is really is another form of free energy, because as it is now, all that potential energy goes down the drain. But with Nitinol engine technology, a significant amount of that thermal energy could be extracted and converted to useful electrical power. Nitinol engines could even be used as a bottoming cycle for steam turbines at, say, nuclear power plants.
Yes, and the authors say, now this is an exact quote from that paper, the principal conclusion to be drawn from this preliminary cost estimate is that Nitinol power plants for low-grade energy conversion may have significant cost advantages over conventional fossil fuel power plants.
And here is a printout, right, from that article. And you know, as you know, we have gone pretty deep into what they wrote about, and although there are a lot of variables in here, we have gone over it, adjusting a lot of it for inflation, and I believe that their conclusion of a significant cost advantage is still applicable today.
I agree, and I would like to point out two additional advantages of Nitinol engines. First of all, they do not have high internal pressures, and they also do not have tight manufacturing tolerances as conventional heat engines do, which make them easier and cheaper to build. So I really hope someone who sees this video will build a Nitinol engine large enough to power a house, and perhaps someday someone will build such an engine in the megawatt range, as was mentioned in the CNN video clip.
That would be awesome. And I really believe that there is a large unused potential in this technology, David. So, in conclusion, to our viewers, besides building a larger Nitinol engine generator, please remember your opportunity to send us your story about witnessing the suppression of free energy technology, and send it in. And David, before we wrap, what are you planning on for our next video?
Such plans can always change, but right now, I think that video 30 could turn out to be more memorable than any other video we have made yet.
Okay. And and you're not going to tell me anything more right
Not
now?
yet.
Okay. So, how do I find out?
Well, just come back and you will find out.
Okay. Then I think all we have left for today is to say thank you.
And see you
next
video.